Stop for a moment, just stop, look around you. What do you see? Maybe you're sitting in a room filled with the soft hum of electricity. Maybe you are looking at the glowing screen of your phone or your computer. Outside your window, perhaps there is the sound of traffic, the honking of cars, or the distant noise of a city that never really sleeps. We live our lives in a rush. We wake up, we check our messages, we drink our coffee, and we run to the next appointment. We worry about deadlines. We stress about tomorrow. We are constantly moving, constantly thinking, constantly doing. But right now, I want you to step away from all of that. I want you to close your eyes for a second, take a deep breath, and imagine you are standing outside. Imagine it is late at night. The air is crisp and cool against your skin. Above you, the ceiling of the world has opened up. It is the night sky. If you live in a city, maybe you only see the moon and a few brave stars fighting against the streetlights. But imagine just for a moment that the city lights are gone. Imagine the true sky, a vast, endless ocean of velvet blackness sprinkled with diamond dust. It looks stunned. It looks still. It looks like a painting that has not changed for thousands of years. But that stillness is a lie. While you stand there breathing in the night air, something is happening. It is happening silently, invisibly, and with terrifying speed. Above your head, hidden in that dark emptiness, a traveller is passing by. We call this traveller Three-Eye Atlas. You cannot see it with your eyes. It is too small, too dark, and too far away for the human eye to catch without help. It does not have flashing lights like an airplane. It does not streak across the sky in a second like a shooting star. To us, it is invisible. But just because you cannot see it does not mean it is not there. It is there and it is watching. This present's Three-Eye Atlas is not like the other rocks and ice balls that float around our neighbourhood in space. Most comets that we see are part of our family. They were born here around our sun, circling round and round like children in a playground. But Three-Eye Atlas is different. It is a stranger. It is a drifter. It is a nomad of the galaxy. To understand this visitor, we must talk about time. Humans are not very good at understanding time. We think 100 years is a long time. We think 2,000 years, the time of the Roman Empire, is ancient history. But for this visitor, 2,000 years is nothing. It is less than the blink of an eye. Let me try to paint a picture of how old this object is. Imagine the Earth 4.5 billion years ago. Before there were humans, before there were dinosaurs, before there were trees or grass or oceans. Back when the Earth was just a ball of hot, angry fire and melted rock. Back then our solar system was just being born. The sun was just waking up. When our Earth was being born, Three-Eye Atlas was already old. This object was formed around a different star far, far away in the deep galaxy. It was born in a time we cannot even comprehend. It saw the birth of its own star system. And then, for reasons we may never know, it was kicked out. It was thrown away by its own gravity, cast out into the cold, lonely darkness between the stars. For millions upon millions of years it drifted. It floated through the absolute zero cold of deep space. It travelled through silence. Think about that silence. No wind, no sound, just endless black empty space. While this stone traveller was drifting, life on Earth began. Single tiny cells started to move in our oceans. The traveller kept moving, fish appeared, the traveller kept moving. Dinosaurs rose up, ruled the planet, and then died out in fire and ash. The traveller kept moving. Mammals appeared, then monkeys. Then finally humans stood up on two legs and looked at the sky. We built pyramids, we fought wars, we invented writing, electricity and the internet. All that time, for billions of years, Three-Eye Atlas was rushing toward us. It was flying through the dark at a speed of over 100,000 kilometers per hour. It was aiming for this precise moment. And now tonight it is here. It feels strange, doesn't it? To think that while you are worrying about what to cook for dinner or what to wear to work tomorrow, there is a piece of history flying over your head that is older than the ground you walk on. It carries dust from a world that died long ago. It carries ice that froze before our sun ever started to shine. It is a ghost from the beginning of time. Why do we call it Three-Eye? In the language of science, the letter I stands for interstellar. It means between stars. We have only seen two of these visitors before. This is the third. That is why it is so special. It is not a local. It does not carry the same chemical fingerprint as the rocks in our own backyard. It is a message in a bottle thrown into the cosmic ocean by a civilization or a star system that is trillions of kilometers away. Right now, as you listen to this, Three-Eye Atlas is diving toward the center of our system. It is getting closer to the sun. The heat is starting to wake it up. For the first time in eons, the ice deep inside its heart is beginning to shift. It is beginning to crack. The warmth of a star is touching its face again. This invisible presence creates a bridge. It connects your short, busy, noisy life with the slow, silent, eternal march of the universe. When you look up at the night sky, you usually feel small, but knowing that 3i Atlas is there should not make you feel small. It should make you feel connected. We are all made of the same stardust. The atoms in your hand are the same kind of atoms locked inside that frozen traveller. You are cousins separated by time and distance meeting for a brief moment in the vastness of space. It will not stay long. It is moving too fast. The sun's gravity tries to grab it, to hold it, to make it stay in orbit like the other planets. But 3i Atlas is moving too quickly. It has too much energy. It will swoop down, say hello to our sun, and then slingshot back out. It will leave us. It will head back out into the interstellar night, never to return. So tonight, give it a moment of your time. Acknowledge the invisible guest. It does not care about our politics. It does not care about our money. It does not care about our borders or our ears. It simply exists, it moves, it survives. It is a witness to the history of the galaxy passing silently through our little corner of space. In the next part of our story, we will look closer. We will strip away the darkness and try to see what this object actually looks like. We will explore the terrifying speed at which it travels and the dangerous dance it is about to perform with the fire of the sun. We will try to understand what secrets are hidden beneath its frozen, dark surface. But for now, just hold the image in your mind. A dark, silent rock, older than the sun, rushing through the void, a messenger from the deep past passing by your window right now. To understand the origins of 3i Atlas, we must first abandon our current reality. We must close our eyes and pull the lever of the cosmic time machine, sending our consciousness hurtling backward against the flow of time. We are not going back a few hundred years or even to the time of the dinosaurs. We are travelling much further deep into the ancient history of the cosmos. We stop the clock at 7 billion years ago. If you were to look out a window into the universe at this specific moment, the sky would look profoundly different from the calm, dark expanse we see today. Today, the universe is in its middle age. It is relatively quiet, stable, and slow-moving. But 7 billion years ago, the universe was in its chaotic, energetic youth. Astronomers often call this era cosmic high noon. It was the peak of activity, a time when the machinery of the cosmos was working at maximum capacity, churning out new stars at a rate that is almost impossible for us to imagine now. In this ancient era, the galaxies were not the polite, organised spirals that we often see in modern telescope images. They were wild and messy. It was a violent time of construction. Smaller galaxies were constantly crashing into one another, merging together in colossal accidents of gravity. These collisions did not destroy them. Instead, they acted like fuel. Every time two galaxies smashed together, clouds of gas were compressed, triggering massive explosions of star formation. The universe was lit up like a fireworks display that never ended. Somewhere in this turbulent sea of young galaxies, there was a specific massive cloud of gas and dust. It was cold and dark, floating in the silence of deep space. This cloud was a nursery, a factory waiting to be switched on. It was composed mostly of hydrogen and helium, the simple fuel left over from the Big Bang, but it was also peppered with dust grains containing heavier elements like carbon and oxygen, the ashes of even older stars that had lived and died long before. Then something disturbed this quiet cloud. Perhaps a shockwave from a nearby supernova, or the gravity of a passing star. The balance was broken, gravity took over. Deep inside this dark cloud, a small pocket of gas began to collapse inward. It grew smaller and tighter. As it shrank, it began to spin faster and faster like an ice skater pulling in their arms. The pressure in the center climbed higher. The temperature began to rise 100 degrees, 1,000 degrees, 1 million degrees. Finally, in a blinding flash of light, nuclear fusion ignited. A new point of light flickered into existence. This was the birth of the system that would eventually create 3i Atlas. It is important to visualize the environment where this happened. It was crowded. Stars back then were often born in massive clusters, thousands of siblings huddled together in the dark. The sky surrounding the infant Atlas was not black. It was likely a vibrant tapestry of glowing nebulas, clouds of gas illuminated by the fierce ultraviolet light of massive blue stars nearby. These giant neighbours lived fast and died young, exploding as supernovae that salted the surrounding space with the chemical ingredients necessary to build rocks, ice, and eventually comets. But while we watch this spectacular birth, there is something hauntingly missing from the picture. If you were to scan the entire Milky Way galaxy at that moment 7 billion years ago searching for home, you would find nothing. There was no Earth, there was no Jupiter, there was no Mars. Even our sun did not exist yet. The matter that makes up your body, the water in our oceans, and the rock of our mountains were all just scattered dust floating in the empty void between the stars. The atoms that would one day form our solar system were drifting aimlessly, perhaps waiting inside a different cloud of gas thousands of light years away from where Atlas was just waking up. This realization brings a sense of profound vertigo. We are used to thinking of the Earth as the center of our story, the solid ground beneath our feet. But in the timeline of 3I, Atlas Earth is a late arrival. When Atlas was forming, condensing out of the ice and dust in that ancient star cluster, our solar system was still more than 2 billion years away from even starting to form. The distance in time is staggering. For 2.5 billion years, a period of time so long that it renders human history meaningless. Atlas drifted through the galaxy without us. It travelled through the spiral arms of the Milky Way, witnessing the death of ancient star clusters and the birth of new ones. It existed in the dark, cold vacuum, a silent traveller moving through the infinite past. Imagine the loneliness of that existence. For eons, 3I Atlas was simply a piece of frozen debris, a dirty snowball locked in a gravitational dance with its own parent star. It saw the universe change. It watched as the frantic star formation of the cosmic high noon began to slow down. It watched as the galaxies settled into more stable shapes. The universe was cooling, stretching and growing quieter. Back then, the chemical makeup of the universe was also slightly different. It was cleaner. There were fewer heavy metals than there are today. The comets and asteroids formed in that era act like time capsules. Because Atlas was born so long ago, its body contains the pristine original recipe of the early universe. It is an artifact from a lost civilization of stars. When we look at 3I Atlas today, we are not just looking at a rock. We are looking at a survivor. It is a ghost from a time before our sun had ever shone. It carries within its frozen ice the story of that chaotic, beautiful and violent universe that existed 7 billion years ago. It reminds us that the universe functioned perfectly well without us for billions of years. We are the newcomers. Atlas is the elder. As the timeline moves forward from that ancient birth, the parent star of Atlas eventually faced its own destiny, perhaps dying or losing its grip on its planets. 3I Sao Atlas was cast out, ejected from the warmth of its home system. It was thrown into the freezing void of interstellar space, doomed to wander alone in the dark. But that's the next part of the story. For now, we leave Atlas there 7 billion years ago, a newborn object in a crowded, bright and violent nursery surrounded by the chaos of a young galaxy, blissfully unaware that billions of years in the future it would cross paths with a small blue planet that did not yet exist. Long before human eyes would ever spot it on a telescope, and long before the Earth had even finished settling into its own comfortable orbit, the story of 3I Atlas began in a place of violent beauty. It was not born in the quiet dark, but in a chaotic, fiery nursery of stars. Picture a massive cloud of gas and dust glowing with the fierce light of newborn suns. In this stellar factory, gravity was the master builder pulling dust grains together to form pebbles, then rocks, and eventually the cores of future planets. 3I Atlas was born in this swirling disk of debris surrounding a young, nameless star. It was likely formed in the colder outer regions of that system, where water and gases froze into hard ice. At this stage, it was just one of trillions of icy fragments, a piece of construction waste left over from the building of a solar system. It was not special yet. It was simply a frozen chunk of rock and ice tumbling through the darkness, waiting for a destiny that would take it far from home. The turning point in its life came from a gravitational dance. As the young planets in that distant system grew larger, they became bullies. A giant planet, perhaps similar in size to our own Jupiter, migrated through the system. Its massive gravity acted like a slingshot. As 3I Atlas drifted too close to this giant world, it was caught in a gravitational tug of war. The giant planet did not swallow the rock. Instead, it flung it outward with tremendous force. This was the Great Kick. In a matter of years, a mere blink of an eye in cosmic time, 3I Atlas was accelerated to a speed that broke the chains of its parent star's gravity. It crossed the invisible boundary of its solar system and entered the terrified unknown. The light of its mother star grew smaller and smaller until it was just another bright dot in the sky, indistinguishable from the millions of other stars. The warmth vanished. The noise of collisions and the chaotic wind of the solar nebula faded away. The door closed behind it. 3I Atlas was now an orphan. Thus began the lonely journey through the interstellar medium, the vast empty ocean between the stars. It's hard for the human mind to comprehend the sheer emptiness of this space. When we look up at the night sky, we see stars that look close together, but in reality they are separated by distances so vast that light takes years to travel between them. For a rock moving at physical speeds, these distances are an eternity. For billions of years, 3I Atlas drifted through this void. It was not a journey with a destination, it was simply a state of existing. The environment it travelled through was not completely empty, but it was the closest thing to nothingness that exists in the universe. The temperature here is almost absolute zero, the point where all thermal energy stops. In this deep freeze, the atoms inside 3I Atlas stopped moving. The object entered a state of deep cryostasis. Any water ice, carbon monoxide ice, or nitrogen ice buried deep within its core became hard as granite, preserved perfectly against the passage of time. It was a sleeping capsule holding the chemical fingerprints of a star system that might have died long ago. But the void was not entirely safe. Even in the emptiness there were invisible hazards. For eons, the object was bombarded by cosmic rays. These are high-energy particles that zip through the galaxy at nearly the speed of light. When these particles struck the surface of 3I Atlas, they did not break it, but they changed it. Over millions of years, this radiation cooked the outer layer of the object. It broke down the chemical bonds of the ices on the surface, creating a dark reddish crust of organic compounds. This crust acted like a shield. While the surface was burned and weathered by the harsh radiation of deep space, the delicate ices inside remained safe, protected by this dark, hardened skin. It was like a cosmic callus built up over billions of years of exposure to the raw elements of the universe. The silence of this journey was absolute. In the vacuum of space, there is no medium for sound to travel. If 3I Atlas cracked or shifted as it cooled, there was no sound. If it passed through a thin cloud of interstellar dust, there was no whisper of wind. It was a silent movie played out on the grandest scale imaginable. It drifted while our own galaxy, the Milky Way, rotated several times. It drifted while life on Earth crawled out of the oceans, learned to walk, and eventually learned to look up. It moved through the darkness with the patience of a stone. It passed other stars, but always at a great distance, never getting close enough to feel their warmth or be captured by their gravity. It was a ghost ship sailing without a captain, without a crew, and without a map. There were moments when it passed through denser regions of the galaxy clouds of molecular gas where new stars were being born. Here it might have collected a fine dusting of new material, adding layers to its story. But mostly it was just the cold, the dark, and the overwhelming solitude. It was a traveller from a forgotten time carrying a message in a bottle that no one was around to read. Then, after countless ages of wandering in the dark, something changed. The backdrop of stars began to shift slightly. One particular star, an average yellow dwarf star, began to grow brighter than the others. It was not special compared to the billions of others, but it lay directly in the path of the wanderer. 3I Atlas did not know it, but its long slumber was approaching an end. Gravity, the same force that had exiled it billions of years ago, was now reaching out to greet it again. The object began to speed up, falling down the gravitational well of our sun. The absolute cold began to soften, rising just a fraction of a degree. The silence remained, but the stage was being set for a violent awakening. After surviving the crushing gravity of its birth, the violent ejection from its home, and the eroding radiation of the interstellar void, 3I Atlas was about to face its greatest challenge, yet the heat of a living star. The ghost was about to enter the light, carrying with it the secrets of a place that no human will ever see. For billions of years, the object known as 3I Atlas knew only the absolute zero of deep space. It was a silent cathedral of ice holding its breath in the void between the stars. It was a statue carved from the dawn of time, perfectly preserved in the dark. But now the long slumber is over. The year is 235 and the silence is breaking. As the comet crosses the invisible boundary that separates the outer dark from the inner warmth, a border astronomers call the frost line, something fundamental begins to change. For eons, the comet was defined by what it held onto. Now it is defined by what it releases. The process begins slowly, almost imperceptibly. As 3I Atlas falls toward the inner solar system, the faint warmth of the sun touches its surface. To a human, this heat would still feel freezing, but to a block of ancient ice that has existed at near absolute zero, it is a scorching fire. The surface does not melt into water. In the vacuum of space, liquids cannot exist easily. Instead, the ice undergoes a violent magical transformation called sublimation. Imagine a block of dry ice on a table vanishing into white smoke without ever leaving a puddle. This is what happens to 3I Atlas, but on a mountainous scale. The frozen skin of the comet turns directly from a solid rock into a gas. This is the first breath of the awakening. Deep inside the comet's crust, pockets of frozen gas, carbon monoxide and nitrogen begin to expand. They have been trapped there since before the Earth was formed. As they heat up, they take up more space. They push against the rocky shell that holds them. Suddenly the pressure becomes too great. Crack! With no sound, because there is no air to carry it, the surface fractures. Jets of gas erupt into the black sky. These are not just random vapors, they are the ghosts of the early solar system. These gases were swirling around the young sun 4.5 billion years ago. They witnessed the birth of Jupiter and Saturn. Now released from their icy prison, they rush out to meet the solar wind, forming a glowing cloud around the nucleus. This cloud is the coma, a fuzzy atmosphere that makes the comet look like a waking eye staring back at the sun. By mid-October 2025, the transformation accelerates. The comet is no longer just rock, it is becoming a dynamic, shifting engine of chemistry. The heat penetrates deeper, reaching layers of frozen water. The water ice screams as it turns to vapor. It drags dust particles with it, tiny grains of silicate and dark organic material. This dust catches the sunlight. What was once a dark, invisible lump is now painting a streak of light across the heavens. The pressure from the sunlight pushes this dust away, forming a tail that stretches for millions of miles. It is a banner announcing the comet's arrival. Then comes the crescendo. It is October the 30th, 2025. This is the day of perihelion, the point in the orbit where 3I Atlas is closest to the sun. The environment here is hostile and violent. The gravitational pull of the sun is immense, stretching and squeezing the comet's body. The heat is intense enough to melt lead. For the comet, this is a moment of pure chaos. The sublimation reaches its peak frenzy. On the surface of 3I Atlas, the scene is apocalyptic. The ground is exploding. Dozens, perhaps hundreds of jets are firing at once, spewing tons of gas and dust every second. The comet is spinning, and as it spins, these jets act like thrusters, tumbling the object through space. It is shedding its mass, violently sacrificing its body to survive the encounter. The gases that are released are complex. It is not just water and carbon dioxide. Instruments on Earth and in space detect traces of ammonia, methane, and complex organic chains, the building blocks of life. In this moment of awakening, the comet is a chemical factory. It is mixing these ancient ingredients, cooking them in the heat of the sun, and scattering them into the void. This is the living phase of the comet. It is not alive in the biological sense. It has no heart, no brain, but it has a metabolism. It consumes its own ice to create energy and movement. It reacts to its environment. It grows a tail that moves and changes with the solar wind. For this brief window of time around October 30th, the cold, dead stone possesses a chemical life. It glows with a fierce green light caused by the breakdown of diatomic carbon and cyanogen molecules under the ultraviolet radiation of the sun. The transformation is total. The object that entered the solar system was a silent, dark traveler. The object that swings around the sun on this day is a roaring beast of light surrounded by a cloud of its own history. The ghosts it releases are now shining brighter than the stars behind them. As 3I Atlas endures this trial by fire, it tells us the story of our own origins. The water vapor rising from its surface is the same kind of water that fills our oceans. The carbon dust blowing away in the tail is the same carbon that makes up our bodies. In its violent awakening, the comet shows us that the cold, dead void of space is actually filled with the potential for life, waiting only for a little warmth to set it free. The encounter on October the 30th is brief but intense. The comet whips around the star, moving at incredible speeds. It survives the furnace, but it is changed forever. It has lost a part of itself, leaving a trail of breadcrumbs in the form of dust and gas that will float in our solar system long after the comet has retreated back into the dark. The awakening is complete, and the sleeper has risen, spoken its message in a language of gas and light, and now prepares to turn its back on the sun once more. The discovery of the object did not happen with a bang, nor with a dramatic gasp from a lonely scientist peering through a lens. In the modern era, astronomy is rarely about a human eye pressed against glass. It is about data silence and the cold, dry air of the high mountains. It began in the Chilean Andes at an altitude where the air is thin and the sky is a perfect piercing black. The date was July 1st, 2025. It was winter in the southern hemisphere. The facility was part of the Atlas network, the Asteroid Terrestrial Impact Last Alert System. This particular telescope was a robotic sentinel, a machine that does not sleep, does not blink, and does not get tired. For most of human history, we looked at the stars and saw constellations, myths, and navigators. Now we look at the stars and see math. On that night, the telescope was performing its routine duty. It was scanning the sky, taking 4 exposures of the same patch of space over a period of time. Its computer brain was looking for one specific thing: movement. Stars are fixed points relative to Earth. They do not move in the span of an hour. But an asteroid or a comet is a traveller. It shifts. The software used a technique called difference imaging. Imagine taking a photograph of a busy street and then taking another one 10 minutes later. If you subtract the first image from the second using a computer, the buildings and the road disappear because they haven't changed. The only things left in the picture are the cars and people, the things that moved. The Atlas system does this with the sky. It subtracts the static universe to reveal the wanderers. At 03:14 AM local time, the algorithm flagged a hit. It was a faint point of light drifting against the background of the constellation Sagittarius. To the machine, it was just another entry in a database of thousands of moving objects. It assigned it a temporary designation, calculated a rough speed, and uploaded the data to the Minor Planet Center in Massachusetts. There were no alarms, red lights did not flash. It was just a line of code sent across the internet. The terror lay in the numbers that the computer had quietly processed. This brings us to the concept of survivor bias. In World War II, the military looked at planes returning from battle to see where they had been shot. They saw bullet holes in the wings and the tail, so they decided to reinforce those areas. But a statistician pointed out they were wrong. They were only looking at the planes that survived to come home. The planes that were hit in the engine or the cockpit never returned. They crashed. Therefore, the military needed to reinforce the places where there were no bullet holes on the survivors. In astronomy, we suffer from a cosmic version of survivor bias. We tend to believe that the universe consists of the things we can see. We see big bright stars because they are big and bright. We see asteroids that reflect sunlight well. We see comets that have long glowing tails. We build our models of reality based on these survivors, the objects that are easy to detect. But space is mostly dark, and it is full of dark things. The object detected on July 1st was an anomaly. It was large, massive in fact, but it was incredibly dark. Its surface was like fresh asphalt, reflecting less than 3% of the light that hit it. For centuries, it had been travelling through the solar system like a ghost in a black room. It had likely passed near us before, perhaps thousands of years ago, but we had no way of seeing it. It was a stealth object hidden not by technology, but by the laws of physics. We were lucky to see it at all. This is the most chilling realization of the discovery. The geometry of the encounter was a statistical miracle. The object was approaching from a direction that usually blinds our telescopes the direction of the sun. Usually objects coming from the day side are invisible until they are right on top of us, because the glare of the sun washes out the sensors. This is a massive blind spot in our planetary defense. However, because of the tilt of the Earth in July and the specific angle of the object's approach, it briefly reflected a glint of sunlight while the telescope in Chile was in the planet's shadow. It was a window of opportunity that lasted only a few days. If the object had arrived 2 weeks later, the angle of the sun would have hidden it completely until it was too late. If it had arrived 2 weeks earlier, the moon might have been too bright in that sector of the sky, drowning out the faint signal. We found it because of a coincidental alignment of orbital mechanics. We found it because we happened to be looking at the exact right pixel of the sky at the exact right minute with the right kind of software. This highlights the profound fragility of human knowledge. We often feel arrogant about our science. We believe we have mapped the solar system. We have apps on our phones that can tell us the name of every star. We feel like the masters of our domain. But this discovery shattered that illusion. It reminded us that we are walking through a dark forest with a very small flashlight. We only know what is in the beam of light. We have no idea what is waiting in the shadows just 3 feet away. Consider the alternative timeline. If this object had arrived 50 years ago in 1975, the story would have been very different. In 1975, astronomy was done with photographic plates, glass squares covered in chemicals. Astronomers had to expose these plates for hours, then develop them in a darkroom, and then examine them with a magnifying glass, looking for tiny specks that had moved. There were no automated systems scanning the entire sky every night. There was no internet to instantly share coordinates between Chile and Massachusetts. There were no high-speed computers to calculate the trajectory in seconds. If this had happened 50 years ago, the object would have remained invisible. The ghost would have continued its approach in total secrecy. The human race would have gone about its daily business, going to work, fighting wars, loving and hating, completely unaware that a hammer was falling from the sky. We would not have had the warning. There would have been no panicked news reports, no evacuation plans, no attempts to deflect it. There would have been only a sudden, blinding flash of light followed by silence. The fact that we saw it on July 1st, 2025 is a testament to human ingenuity, yes. We built the machines that found it. But it is also a testament to sheer terrifying luck. We happened to be awake when the thief entered the house. As the data from Chile was verified, and as other telescopes around the world swung to track the new coordinates, the accident of the observation became clear. We had caught a glimpse of something that did not want to be seen. We had overcome the survivor bias of the cosmos, if only for a moment. But as the scientists looked at the calculated path of the object, the relief of discovery was quickly replaced by a cold dread. The math did not care about luck. The math was absolute. The trajectory was not a near miss. It was an intersection. The accidental observer had found the bullet. But now we had to realize that the bullet was aimed at us. To understand the profound importance of 3i Atlas, we cannot look at it in isolation. We must place it in a lineup with the two visitors that came before it. For decades, astronomers stared into the darkness, waiting for a sign that our solar system was not alone in the galaxy. We waited for a rock, a stone, or a snowball to cross the vast distance between the stars and enter our home. When that finally happened, it did not happen just once. In a very short window of time, humanity was visited by three distinct messengers. These three objects, 1i Oumuamua, 2i Borisov, and now 3i Atlas, form a perfect trilogy. They are like three chapters in a book that tells the story of how planets are born and how they die. But while the first two are messengers of the present, Atlas is a ghost from the deep past. Let us look back at the first messenger. When 1i Oumuamua arrived in late 2017, it broke every expectation we had. It was the question. It was baffling. It did not look like a comet, nor did it look like an asteroid. It was shaped strangely, perhaps like a long cigar or a flat pancake. It tumbled through space rather than spinning smoothly. Most confusing of all, it accelerated as it moved away from the sun, yet it showed no visible tail, no gas, and no dust. Oumuamua was a shock to the system. It forced scientists to argue and debate. Was it a hydrogen iceberg? Was it a shard of a destroyed planet? Some even dared to whisper the word aliens, though that was unlikely. Once, Oumuamua represented the mystery of the galaxy. It told us that other solar systems are doing things we do not fully understand. It was a messenger of chaos, a piece of debris that had been hardened by cosmic radiation, stripped of its ice, and left as a dark red skeleton tumbling through the void. It was a traveller that refused to share its secrets. Then 2 years later came the second messenger, 2i Borisov. If Oumuamua was the confusing stranger, Borisov was the familiar friend. It was the answer. When we looked at Borisov through our telescopes, we breathed a sigh of relief. It looked exactly like the comets we have in our own solar system. It had a fuzzy atmosphere. It had a tail. It was made of water ice and dust. Borisov was comforting. It proved that the laws of physics and chemistry are the same elsewhere in the galaxy. It told us that other stars build comets just like our sun does. We could analyze its chemistry and find oxygen and carbon in ratios that made sense. Borisov was the control group in this grand experiment, proving that not everything in deep space is a monster like Oumuamua. But then we discovered the third messenger, 3i Atlas. If Oumuamua is the mystery and Borisov is the standard, then Atlas is the history. This is where the comparison becomes fascinating. The fundamental difference between Atlas and the two previous visitors is not just about shape or speed, it is about age. The first two visitors, Oumuamua and Borisov, were likely ejected from their home systems after planets had already formed. They were the leftovers of a finished construction project. They were like bricks thrown out of a house that had already been built. They had spent millions, perhaps billions of years floating in the cold darkness before reaching us. They were mature objects. 3i Atlas is different. The data suggests that Atlas is primordial. This means it is not a leftover from a finished system. It is a raw ingredient from a system that was just beginning to form. It is a time capsule from the very first moments of a solar system's life. When we study the chemical composition of Atlas, we see that it is incredibly rich in carbon monoxide and nitrogen. These are super volatile ices that turn into gas at extremely low temperatures. A standard comet loses these volatile ices over time if it gets too close to a star or lives too long. The fact that Atlas is packed full of them tells us that it has never been warm. It has never been processed. It is a pristine, untouched sample of the dust and gas cloud that creates stars. This difference in age changes everything about how we view it. When Oumuamua passed by, we were looking at a scarred survivor. When Borisov passed by, we were looking at a typical traveller. But with Atlas, we are looking at an embryo. We are seeing the raw material that existed before planets like Earth or Jupiter could even be born. Comparing their structural integrity reveals another layer of this story. Oumuamua was hard as rock, seemingly indestructible as it tumbled. Borisov was solid enough to survive its journey around the sun, but Atlas was fragile. It was barely held together. As it approached the heat of the sun, it began to fragment and shatter. At first, this shattering seemed like a failure. We wanted it to survive so we could watch it longer, but scientifically the shattering of Atlas was a gift. Because it was so young and fragile, it cracked open like an egg. It allowed us to see its insides. With Oumuamua, we could only look at the surface. With Atlas, the object destroyed itself to show us its heart. It revealed that the building blocks of planets are not solid rocks, but fluffy, icy clumps of dust that gently come together in the cold dark. It showed us that the early stages of planetary formation are chaotic and delicate. Atlas was likely ejected from its home star not by a giant planet, but by the turbulence of the gas cloud itself, thrown out before it could ever become part of a world. This brings us to the evolution of human understanding through these three messengers. When One-Eye Oumuamua arrived, our reaction was surprise. We realized we were blind to the traffic in our galaxy. It woke us up. It forced us to build better detection software and scan the sky faster. When Two-Eye Borisov arrived, our reaction was validation. We validated our models. We confirmed that our understanding of cometary formation was correct and applicable to the wider universe. When Three-Eye Atlas arrived, our reaction was a breakthrough. We moved from simply cataloguing these objects to doing interstellar archaeology. We are no longer just looking at rocks. We are looking at the fossilized remains of star systems. Atlas allows us to travel back in time, not just to the birth of its home star, but to the birth of our own. By studying the carbon and oxygen inside Atlas, we are looking in a mirror at the chemical soup that eventually created the Earth 4.5 billion years ago. The narrative of these three messengers is a progression from the weird to the familiar and finally to the fundamental. Oumuamua asked, "What is out there?" Borisov replied, "Things like us are out there." Atlas added, "And this is how we all began." It is the chemical fingerprint of Atlas that serves as the final distinguishing factor. While Borisov released water vapor similar to our ocean's Atlas released huge plumes of carbon-based gases, this suggests it formed in the coldest, darkest outer edge of a protoplanetary disk, the shadow zone where temperatures are near absolute zero. It is a place we cannot easily study in our own solar system because the evidence has been erased by the sun's heat over billions of years. Atlas brought that evidence to our doorstep. In conclusion, while One-Eye Oumuamua will always be famous for being the first and Two-Eye Borisov for being the first normal, Three-Eye Atlas may turn out to be the most scientifically valuable. It bridges the gap between astronomy and history. It is not just a traveller through space, it is a traveller through time. It reminds us that the galaxy is not just full of dead rocks, but is alive with the constant process of creation and destruction. Atlas died fragmenting into dust so that we could understand the life of the stars. The universe has a way of keeping secrets, but it also has a way of whispering them if we know how to listen. On October 28, 2025, the Neil Gehrels Swift Observatory listened closely to the visitor passing through our system, and it heard a whisper that changed our understanding of our place in the cosmos. It was not a sound made of vibrations, but a signature written in ultraviolet light. It was the signature of water. To understand why this moment was so historic, we must first look at the instrument that made it possible. The Swift Observatory is a robotic satellite that orbits our planet designed to look at the universe in wavelengths that the human eye cannot see. We are blind to ultraviolet light, but for astronomers it is one of the most important tools for understanding the chemistry of space. While telescopes on the ground struggle to see through our own atmosphere, Swift floats high above watching the dark sky with perfect clarity. When the interstellar comet moved closer to the sun, the rising heat began to wake it up from a sleep that had lasted for eons. For millions of years, this comet had been a frozen, silent rock travelling through the deep, absolute cold between stars. But as it approached our star, the warmth caused the ices on its surface to turn directly into gas. This process creates a massive cloud around the solid core of the comet, which astronomers call a coma. Within this expanding cloud of gas, a violent chemical reaction was taking place. The sun's powerful ultraviolet light struck the water molecules that were lifting off the comet. A water molecule is usually made of 2 hydrogen atoms and 1 oxygen atom holding onto each other tightly. However, the harsh light from the sun is strong enough to break this bond. It knocks 1 hydrogen atom away, leaving behind a pair, 1 oxygen atom and 1 hydrogen atom. In the language of chemistry, this remaining pair is called hydroxyl. This is exactly what the Swift satellite saw. It did not see liquid water flowing like a river or an ocean. It detected the specific glowing light that hydroxyl emits when it is energized by the sun. Finding hydroxyl is considered the smoking gun of astronomy. If you see hydroxyl, you know for a fact that there was water there to begin with. It is the chemical echo of water being destroyed by sunlight. The ancient traveller. The discovery of water on a comet is not new in itself. We have found water on comets that belong to our own solar system many times. But this visitor was different. It did not come from the cloud of rocks that surrounds our sun. It came from a completely different star system, perhaps from a star that died long ago, or one that is still shining in a constellation we only see as a faint dot in the night sky. This means the water detected on October the 28th is technically alien water. However, calling it alien creates a sense of separation that is not quite true. The most profound realization from this discovery is not that the water is different, but that it is exactly the same. This brings us to the concept of the memory of water. Imagine the journey of the water molecules on that comet. Billions of years ago, in a vast cloud of gas and dust far from here, an oxygen atom met 2 hydrogen atoms. They stuck to the surface of a tiny grain of cosmic dust. Over time, they formed ice. That ice became part of a comet, which was then kicked out of its home system by the gravity of a giant planet. It drifted alone in the total darkness of interstellar space for billions of years, holding that water frozen in a deep sleep, preserving it like a diamond in a vault. When Swift detected that hydroxyl signal, it was unlocking a time capsule. We were looking at water that formed around a different sun long before humans, or perhaps even the Earth, existed. It is water that has seen the silence of the void and the birth of stars. Cosmic chemistry and universality. This discovery confirmed a beautiful and grounding truth about our universe. Chemistry is universal. The laws of physics that govern a drop of rain falling on a green leaf in Vietnam are the exact same laws that govern the ice on a comet light years away. Water is simple, it is just oxygen and hydrogen. Hydrogen is the most common element in the universe created. The Big Bang. Oxygen is created inside the burning hearts of massive stars. When these stars explode, they spread oxygen across the galaxy like seeds in the wind. Therefore, the ingredients for water are everywhere. This leads to a thought that is both scientific and deeply emotional. Think about the water in your own body right now. The water in your blood, the moisture in your breath, the tears in your eyes. Every single molecule of water inside you has a history. The hydrogen atoms in your body are billions of years old, dating back to the very beginning of time. Now look back at the comet. The water evaporating off its surface is physically identical to the water in your body. If you could take a cup of that ancient comet water, filter it and drink it, it would hydrate you just as well as water from a mountain spring on Earth. It would act as a solvent. It would regulate your temperature. It would become part of your cells. There is no such thing as Earth water versus wastewater. There is just water. It is the common thread that ties all life and all planetary systems together. We are not chemically special, we are chemically connected. The significance of the signal. The detection of hydroxyl on October the 28th was remarkably strong. The Swift Observatory measured that the comet was shedding an enormous amount of water, thousands of gallons every single second. This tells us that water is not rare in the galaxy. If a random rock drifting through space is loaded with water, it suggests that other planetary systems are likely wet too. This has massive implications for the search for life beyond Earth. Water is the stage upon which life dances. We know of no life form that can exist without it. It dissolves nutrients, it transports chemicals, and it provides a stable environment for delicate biological reactions to occur. By finding such a clear signal of ancient water from another star system, we are essentially finding the starter kit for life. It supports the theory that comets act as cosmic delivery trucks. Early in the history of a solar system, planets are often hot and dry. Comets crashing into these young planets deliver their cargo of water and organic molecules. It is entirely possible that the water in our oceans was delivered by comets similar to this one. In a way, when we look at this interstellar visitor, we are looking at our own origins. We are seeing the mechanism that might have turned Earth from a dry, barren rock into the blue marble we call home. A mirror across the stars. As the data streamed down from the satellite to the ground stations, the scientists were not just looking at graphs and numbers. They were witnessing a reunion. The water on the comet had travelled across the unimaginable emptiness of the void to reach us. For a brief moment as it passed our sun, it released its memory, the chemical signature it had held frozen since its birth. It reminds us that we are not isolated in a dark corner of the universe. We are made of the same star stuff as the rest of the galaxy. The distance between us and the stars is measured in light years, but the chemical distance is zero. The hydroxyl molecule glowing in the ultraviolet light of the comet is a twin to the molecules flowing through our veins. We are connected to the cosmos, not just by gravity or light, but by the very substance that makes us alive. The comet is a messenger, and the message is clear. We are part of a vast watery universe, and the potential for life is written into the very chemistry of the stars. For a long time we looked at our Earth as if it were a lonely island in the middle of a vast empty ocean. We imagined that the walls of our solar system were high and thick, protecting us, or perhaps trapping us in solitude. We believed that life was a miracle that happened only here, a lightning strike of luck that struck a single blue marble and nowhere else. But as we look closer at the dust that drifts between the stars, that feeling of isolation is beginning to fade. We are learning that the Earth is not a fortress. It is a garden with its windows open, and the wind blowing through those windows carries the seeds of the cosmos. This brings us to one of the most fascinating and romantic ideas in astronomy, the hypothesis of panspermia. The word itself comes from Greek meaning seeds everywhere. It is the idea that life, or at least the essential ingredients for life, does not strictly originate on the planet where it is found. Instead, these seeds of life might be drifting through the universe, hitchhiking on comets, riding on asteroids, or floating in microscopic dust, waiting to fall upon a fertile world where they can wake up and grow. We must approach this idea with caution. We have not yet found a living alien microbe hitching a ride on a meteor. We have not found direct proof that our ancestors came from the stars. However, we have found something almost as profound: we are not chemically alone. When astronomers point their telescopes at distant clouds of gas and dust, at the dark swirling nebulas where new stars are born, they do not see empty space. They see chemistry. Using the light from these clouds, we can analyze what they are made of. We have found water, the essential solvent for life as we know it. We have found carbon, hydrogen, nitrogen, and oxygen. But more surprisingly, we have found complex organic molecules. We have discovered amino acids, which are the building blocks of proteins. We have found the basic structures of sugar and alcohol. Getty images. This tells us something incredible. The universe knows how to bake the cake of life. It has all the ingredients in its pantry, and it is mixing them together in the vast spaces between the stars. The chemistry that makes your blood flow and your brain think is not unique to Earth. It is universal chemistry. The universe is awash in the potential for life. It seems that nature wants to create life, and it scatters the raw materials across the galaxy like a farmer sowing seeds in a field. But how do these seeds move? How does material travel from one star system to another? For years, we thought our solar system was a closed loop. The planets orbit the sun, the moons orbit the planets, and everything stays in its lane. But we now know this is not true. The solar system is a chaotic and dynamic place. In the early days of our history, giant rocks crashed into planets with terrifying force. When a massive asteroid hits a planet like Mars or Earth, it can blast rocks from the surface all the way out into space, escaping the planet's gravity. These rocks become travelers. They float through the dark for millions of years. Eventually, gravity might pull them onto another world. We have found rocks here on Earth that we know chemically and geologically came from Mars. If life existed on Mars billions of years ago, could microbes have been trapped inside those rocks? Could they have survived the freeze of space and the heat of entry to land on Earth? It is a maybe that keeps scientists awake at night. Shutterstock. Even more expansive is the idea of exchange between solar systems. We used to think the distance between stars was too great for objects to cross, but recently we were visited by an object named Oumuamua. It was a strange cigar-shaped rock that zoomed through our solar system. Based on its speed and trajectory, we know for a fact that it did not come from our sun, it came from another star. Oumuamua was a messenger. It proved that rocks are constantly being ejected from other star systems and flying through the galaxy. If the Milky Way galaxy is billions of years old, imagine how much material has been traded between stars. It creates a picture of a galactic ecosystem. We are not just recycling our own water and air, we are slowly over eons sharing matter with the rest of the galaxy. This realization forces us to be humble. We like to draw lines on maps, we draw lines between countries, and we draw lines between our planet and the rest of space. We say this is Earth and that is space. But nature does not care about our lines. The Earth is constantly bombarded by tons of cosmic dust every day. This dust contains the chemical history of the stars. The air you breathe contains atoms that were once part of distant suns. Panspermia does not necessarily mean that little green men landed here and planted a garden. It is more likely a soft panspermia, a molecular delivery service. Perhaps the early Earth was hot and barren, unable to produce the complex molecules needed for life. Perhaps comets, which are essentially dirty snowballs from the edge of the solar system, crashed into our young planet. They didn't just bring water to fill our oceans, they brought the menu for the feast of life. They delivered the carbon compounds and the frozen organics that gave life the kickstart it needed. In this view, life is not a local accident, it is a cosmic imperative. It suggests that biology is the eventual purpose of chemistry. If you wait long enough and if you spread the seeds wide enough, life will happen. This makes the universe feel less cold. When we look up at the night sky, we are not looking at a hostile void. We are looking at our extended family tree. The comets are the bees of the galaxy cross-pollinating the planets. The asteroids are the carriers of potential. So as we continue to search for life on Mars or on the icy moons of Jupiter or on planets circling distant stars, we are essentially looking in the mirror. We are looking for our chemical cousins. We are realizing that the Earth is just one flower in a very large meadow, and the same wind that blew the seeds here has surely blown them elsewhere. We are made of stardust, yes, but we are also the children of a wandering universe connected to the furthest reaches of the galaxy by the invisible drifting seeds of life. The excitement of the discovery phase often masks the brutal reality of astronomy. The universe does not wait for us. As soon as 3I Atlas was identified as an interstellar visitor, the clock began to tick with a merciless rhythm. For the scientists on the ground, the experience was not just one of wonder, but of a desperate high-speed chase where the runner was already halfway across the finish line before the starting gun was even fired. The primary difficulty lay in the sheer mechanics of the encounter. When we think of space observation, we often imagine astronomers leisurely gazing through lenses, taking their time to study the stars. However, observing 3I Atlas was nothing like that. It was more like trying to take a clear photograph of a speeding bullet while standing on a carousel that is spinning in the opposite direction. The object was moving at velocities that are hard for the human mind to truly comprehend, travelling at tens of kilometres every single second. Because 3I Atlas originated from outside our solar system, it was not bound by the comfortable circular orbits that govern the planets and asteroids we are used to. It dropped in on a steep hyperbolic trajectory, diving toward the sun and then slinging back out into the deep blackness. This meant that the geometry of the observation changed every single night. One night the object might be visible for 2 hours before the sun rose. The next night it might be visible for only 90 minutes. The window of opportunity was incredibly brief. In the vast timescale of the cosmos where events play out over billions of years, the visit of 3I Atlas lasted less than a blink of an eye. It was a matter of weeks, not years. During this short period, astronomers had to battle not only the speed of the object but also the limitations of life on Earth. Weather was a constant enemy. A single week of cloudy skies over a major observatory meant that a significant percentage of the total viewing time was lost forever. There were nights when the telescope domes had to remain closed due to high winds or humidity, leaving the astronomers inside helpless, as they knew the object was racing away unobserved directly above their heads. The frustration in those control rooms was palpable. They knew that every second lost was a piece of data that would never be recovered. Furthermore, the object itself did not want to be seen. It was small and incredibly dark. Its surface reflected very little sunlight, making it appear as faint as a candle flame viewed from hundreds of kilometers away. As it moved away from the sun, its brightness dropped exponentially. It faded from the view of amateur telescopes within days, and soon after even the mid-sized professional observatories could no longer track it. Eventually only the most powerful eyes on Earth, the giant telescopes with mirrors measuring 8 or 10 meters across and the space telescopes orbiting above the atmosphere, could see it. And then even they began to struggle. The signal-to-noise ratio dropped. 3I Atlas became a ghostly smudge of pixels on a screen indistinguishable from the background static of the universe. This fading away brought with it a profound sense of regret. It is a specific kind of scientific melancholy known well to those who study transient events. As 3I Atlas crossed the orbit of Mars and headed toward the outer darkness, it took with it a cargo of unsolved mysteries. We had so many questions that remained unanswered. We never got a clear picture of its surface. We saw only the light reflecting off it, not the object itself. Was it cratered and scarred from a billion-year journey? Was it smooth and metallic? We do not know. We never found out exactly what it was made of. Spectrometers gave us hints, suggestions of carbon, perhaps some organic compounds or silicates, but we lacked the time to perform a deep definitive analysis. Perhaps the biggest regret was our inability to physically reach it. The dream of every planetary scientist is a sample return mission to land a robot, grab a piece of the rock and bring it home. But the physics of the encounter made this impossible with our current technology. To catch up with 3I Atlas, a spacecraft would have needed to launch immediately and travel faster than any rocket we have ever built. By the time we realized the object was there, it was already too late to pack our bags. We were stuck on Earth watching the train leave the station, unable to jump aboard. As the final data points came in becoming increasingly erratic and unreliable, the reality set in. 3I Atlas was gone. It would never return. Unlike Halley's Comet, which visits us once in a human lifetime, this visitor is on a one-way trip. It will continue to drift through the void of the Milky Way, passing other stars and perhaps other civilizations carrying the secrets of its origin with it. This moment highlights the stark contrast between our ambition and our capability. We live in an age of technological marvels. We carry supercomputers in our pockets, we have mapped the human genome, we have rovers driving on Mars. Yet when faced with the true scale and speed of the universe, we are reminded of how small we really are. Our most advanced telescopes are still limited by the laws of optics and the sensitivity of sensors. Our fastest rockets are still too slow to catch an interstellar traveller. The departure of 3I Atlas serves as a humbling lesson in humility. It reminds us that the universe is not static. It is dynamic and constantly changing. Events happen whether we are watching them or not. There are likely thousands of objects like 3I Atlas passing through our neighbourhood, all the time unseen because they are too small, too dark, or we simply weren't looking in the right direction at the right time. In the end, the files were saved, the papers were written, and the telescopes were slewed to point at new targets. But for the team that tracked it, a sense of what if lingers. What if we had seen it a month earlier? What if we had a rocket ready on the launch pad? What if we could have seen just a little bit close? The fleeting moment has passed. The dark visitor has returned to the shadows from which it came, leaving us with terabytes of data, but leaving the greatest mystery, the story of its true nature, unsolved. We are left standing on the shore of the cosmic ocean, watching the ships sail over the horizon, realizing that for all our knowledge, there are still vast depths that we cannot yet reach. For decades, science fiction has promised us a specific version of the future. In these stories, humanity builds massive ships with shiny engines. We defy gravity, we break the speed of light limit, and we zip between star systems as easily as taking a flight from London to New York. We have always assumed that to understand the universe, we must physically leave our home and travel into the deep dark. However, the reality of physics teaches us a harsh lesson about distance. The gaps between stars are not just empty space, they are vast oceans of silence that defy human comprehension. The nearest star system to us, Alpha Centauri, is over 4 light-years away. In simple terms, if we used our fastest current chemical rockets, it would take us roughly 70,000 years to get there. Even with nuclear engines or advanced lasers pushing light sails, the journey would take decades or centuries. But recently, our perspective has shifted. We have realized that we do not always need to cross the ocean to find new lands. Sometimes the ocean currents bring driftwood messages and treasures to our shores. The universe comes to us. The turning point in this thinking happened recently with the discovery of objects like Oumuamua and Comet Borisov. These were not normal rocks from our own solar system. They were visitors. They came from the space between stars, passed near our sun, and then left forever. This changed everything. It proved that the galaxy is not a series of isolated islands. Instead, it is a busy highway. Solar systems are messy places. When planets form, gravity kicks out trillions of rocks, ice chunks, and dust particles. These fragments wander the galaxy for millions or billions of years. Eventually, some of them drift into our solar system. Instead of spending trillions of dollars and thousands of years trying to send a human to a distant star to pick up a rock, we simply need to wait. The stars are sending pieces of themselves to us. The challenge of the catch. This realization leads to a new kind of space mission, the Interceptor. Catching an interstellar object is incredibly difficult. These objects do not follow the circular paths of our planets. They fall into our system at extremely high speeds, often moving at tens of kilometers per second faster than anything orbiting the sun. They appear suddenly in our telescopes, zip past the sun, and disappear back into the dark within a few months. To catch one, we cannot wait until we see it to launch a rocket. By the time the rocket is ready on the launch pad, the object will be gone. The solution is a strategy of active waiting. In the near future, space agencies will likely park robotic spacecraft in deep space far away from Earth. These spacecraft will be like goalkeepers waiting for a penalty kick. They will sit in stable positions, perhaps at points where the gravity of the Earth and the Sun balance each other out and sleep. When our powerful telescopes spot a visitor coming from deep space, the goalkeeper wakes up. Because it is already in space, it does not need to fight Earth's gravity to escape the atmosphere. It can use all its fuel to chase the visitor. The goal is not necessarily to stop the object that would require too much energy. The goal is to match its speed and fly alongside it for a few weeks. During this brief rendezvous, the probe could take photos, sniff the gases coming off the object, and perhaps even shoot a small projectile into the surface to kick up dust and analyze the chemistry, examining the message in the bottle. Why is this so important? Because a single gram of material from an interstellar object is worth more than its weight in gold. If we could analyze a rock from another star system, we could look at the isotopes, the different versions of atoms inside the material. This would tell us how that star system formed. Was it born in a violent supernova explosion? Does it have the same water mixture as Earth? Does it contain complex carbon chains, the building blocks of life? We could effectively study the geology of a planet 10 light years away without ever leaving our own backyard. It is the ultimate efficiency. It is the difference between building a boat to cross the Atlantic and simply picking up a message in a bottle that washed up on the beach. A vision for the next 100 years. This brings us to the vision for humanity over the next century. The space age of the 60s was about planting flags and footprints. The space age of the next 100 years will be about building a nervous system for our solar system. We will likely move away from the idea of conquering space with brute force. Instead, we will build a sensitive web of eyes and ears. 1. The Great Survey. In the next few decades, we will launch telescopes specifically designed to map the invisible debris around us. We will stop looking only at the bright stars and start looking at the shadows. We will map the millions of rocks that cross our path. 2. The Interceptor Fleet. By the year 2075 or 2100, humanity will likely have a permanent fleet of rapid response drones stationed near the orbit of Jupiter or Saturn. These machines will be autonomous, powered by nuclear batteries ready to sprint toward any object that enters our domain. 3. The Sample Return. The ultimate prize within the next century would be to not just fly by an interstellar object, but to capture a small piece of it and bring it back to Earth. Imagine a laboratory in Paris or Tokyo holding a piece of ice that formed around a dying star 5 billion years ago. Humility in the vastness. This approach teaches us a profound lesson about our place in the cosmos. It teaches us humility. For a long time, humans believed that we are the center of action, that we must go out and impose our will on the galaxy. But the lessons in distance tell us that we are small. The distances are too great for us to conquer with force. However, the universe is also more connected than we thought. We are not isolated. We are constantly being bombarded by the history of other worlds. By shifting our focus from traveling there to understanding what comes here, we mature as a species. We stop being like children running aimlessly into the dark woods, and we become like a wise watchman sitting in a tall tower, observing the movement of the forest. In the next century, we may not walk on the surface of an exoplanet. We may not meet aliens face to face, but if we are smart, if we are patient, and if we build the right nets, we will hold the pieces of those distant worlds in our hands. We will realize that the stars have been trying to touch us all along. We just weren't ready to catch them until now. As the comet begins its long journey back into the deep freeze of the outer solar system, fading from our view, we are left with a silence. But this silence is not empty. In this quiet moment, we must look past the data, the numbers, and the pictures we have collected. We need to look at something that cannot be measured by a machine, but can only be felt by the mind. We need to look at the invisible thread that ties us to that ball of ice and dust. When you look at your own hand, what do you see? You see skin, you see veins, you see life. But if you could look deeper past the cells and into the very building blocks of your existence, you would see atoms. You would see carbon, nitrogen, oxygen, and iron. These are the ingredients that make you human. Now think about the comet. If we take a piece of that comet and analyze it, what do we find? We find the exact same things: carbon, nitrogen, oxygen, and iron. This is not a coincidence. It is the most profound truth of our reality. The atoms that are currently inside your body allowing you to breathe and think, and the atoms that are frozen in the crust of that distant comet share the same mother. They were both born inside the fiery heart of a dying star billions of years ago. When that star exploded, it threw these atoms out into the darkness. Some of them clumped together to form the Earth and eventually became you. Others clumped together to form the comet. You and the comet are effectively cousins separated by time and space but made of the exact same stardust. This shared history tells us that we are not separate from the universe. Often humans feel like we are small creatures living on a planet looking up at the sky. We feel like the universe is something out there far away from our daily lives. But the atomic connection proves that this is wrong. The universe is not outside of you. The universe is inside of you. The iron in your blood that carries oxygen to your brain is the same iron found in asteroids and stars. We are a way for the universe to know itself. This brings us to a concept that is often misunderstood, the idea of the cosmic conversation. When we hear the word conversation, we usually think of two people talking, or perhaps sending a text message. We think of language, words, and grammar. Because of science fiction movies, when we say cosmic conversation, people often imagine radio signals from aliens or secret codes from a spaceship. We imagine little green men trying to say hello, but the reality is much more beautiful, much more complex, and much more real than fiction. The cosmic conversation is not about aliens, it is about physics. It is the way the universe communicates with itself. Since we are part of the universe, it is how the universe communicates with us. This conversation does not use words, it uses forces light and matter. It is a dialogue that has been happening for billions of years, long before humans invented ears to hear or mouths to speak. Think about gravity. Gravity is often described in school as just a force that pulls things down. But in the language of the cosmos, gravity is a touch. It is the way one object says to another, I am here. When the comet passes by the sun pulls on it and the comet speeds up. That is a conversation. When the comet flies past the Earth, even though it is millions of miles away, the Earth feels a tiny invisible tug and the comet feels the Earth. They are acknowledging each other across the void. It is a silent dance where the partners never touch, yet they move in perfect harmony because they feel each other's presence. Then there is the language of light. The comet does not have a voice, but it shines. When the sun's heat hits the comet, gas glows and dust reflects the sunlight. That light travels through the emptiness of space for minutes or hours until it hits a telescope or perhaps your human eye. In that moment, a physical connection is made. A photon, a tiny packet of light that was created by the interaction of the sun and the comet, has physically entered your eye. It has touched your retina. Information has been transferred. The comet has told you its temperature, its speed, and what it is made of, all through the language of light. We interpret this language using the tools of science. When we split that light into a rainbow of colours, we can see dark lines that act like a barcode. This barcode tells us which chemical elements are on the comet. Without ever going there, without ever taking a sample, we know the comet contains water and carbon. The comet told us this through the light it reflected. This is the cosmic conversation. It is the continuous exchange of energy and information between all things in the universe. Understanding this changes how we see our place in the story. We often view space exploration as humans looking at external things. We act as if the universe is a stage, and we are the audience watching the show. We look at the comet and think, that is a strange object over there. But the philosophy of the invisible connection tells us that there is no over there. There is only here. The universe is a single vast interconnected web. The comet is not a stranger visiting us. It is a piece of the same puzzle. We are not just observers watching the universe happen. We are the universe experiencing itself. When you learn about the comet, it is the universe learning about itself. When you marvel at its beauty, it is the universe admiring its own creation. This perspective removes the fear of the vast emptiness. Space is often called a cold, dark void. It can feel lonely. But if you understand the invisible connection, you realize you are never truly alone. You are connected to the comet by the gravity that anchors you to the planet. You are connected to the stars by the atoms in your blood. You are connected to the history of time by the water in your glass, which might have been delivered to Earth by a comet just like this one, billions of years ago. Think about that glass of water. The hydrogen atoms in that water were created moments after the universe began. The oxygen atoms were forged in a star. They combined to form water, froze onto a comet, crashed into early Earth, and eventually became the ocean, the rain, and the drink in your hand. When you drink water, you are drinking the history of the cosmos. You are drinking a comet. We are a part of a story that started with the beginning of time and is still being written today. The comet is a chapter from the beginning of the book preserved in ice. We are a chapter from the middle of the book written in life and consciousness. By studying the comet, we are essentially reading our own history. We are looking at our baby pictures. So as the comet fades into the darkness, do not think of it as leaving. Think of it as a messenger that stopped by to remind us of our heritage. It reminded us that we are not small isolated creatures living on a lonely rock. We are giants in our own right, made of the same durable material as the stars, capable of understanding the silent language of gravity and light. The cosmic conversation continues every day. It happens every time you feel the warmth of the sun on your face. That warmth is energy that travelled 93 million miles just to touch your skin. It happens every time you look at the moon and feel a sense of wonder. It happens every time you take a breath of air. You are interacting with the cosmos constantly. The comet was just a loud, beautiful sentence in a long dialogue that will last forever. We do not need to wait for aliens to feel connected to the sky. We do not need spaceships to be part of the universe. The connection is already there, written in the laws of physics and flowing through our veins. We just need to remember to stop, look up, and listen to the silence. And now we reach the end. We have travelled a long way together. From the moment we first spotted that strange wandering light in the distance to the heat of its approach and through the grandeur of its closest pass. But now the journey changes. The excitement of discovery settles into the comfort of departure. Close your eyes now if you haven't already. Let the heavy curtains of your room block out the world. Let your body sink into the mattress, feeling the gentle pull of gravity. This is not the heavy gravity that crushes. It is the grounding gravity that holds you safe. It is the same force that keeps the moon dancing with the earth and the earth dancing with the sun. You are held, you are supported, you are safe. Far above you, beyond the ceiling, beyond the clouds and beyond the blue atmosphere, the comet 3I Atlas is saying goodbye. Imagine it now. It is no longer the bright, fiery object we saw weeks ago. It is moving away from the sun. It is gliding into the shadows. As it travels, the heat of our star fades behind it. The tail of gas and dust, which once stretched out for millions of kilometers like a magnificent banner, is quieting down. It is becoming thin. It is becoming a ghost of its former self. The comet is crossing the invisible border of our neighborhood. It floats past the orbit of Neptune. It drifts silently into the Kuiper Belt, that ring of frozen worlds and ancient ice. Here the sun is just a very bright star in the distance. It is no longer a ball of fire. It is a point of light, watching quietly. There is no sound here. Imagine that silence. It is a perfect deep silence. There is no wind to rustle the leaves. There are no cars on the highway. There are no ticking clocks. There is only the vast open space. It is peaceful. It is a silence that allows you to finally hear your own heartbeat, slow and steady. Let your breath match the movement of the comet. Slow, giddy, without effort. Inhale deeply, imagining the cool, crisp air of the cosmos filling your lungs. Exhale completely and letting go of the heat and the noise of your day. The comet does not struggle to move. It does not need an engine. It does not need to push. It simply drifts. It follows the path laid out for it by the laws of the universe. It surrenders to the drift. I want you to surrender to the drift now. Feel your toes relaxing. Feel your ankles becoming loose. The tension flows out of your legs, leaving them heavy and warm. Your hands are resting gently. Your shoulders drop away from your ears. There is nothing you need to carry right now. The comet carries nothing but ice and dust, and you need to carry nothing but the intention to rest. Atlas is now entering the deep dark. The temperature drops. It is hundreds of degrees below zero, but in your mind, this cold is not harsh. It is the refreshing, cool side of the pillow. It is the stillness of a winter night. The comet becomes a dark wanderer again. It is returning to the anonymity of the void. Think about the destination. It is heading toward the Oort cloud, a shell of icy objects that wraps around our solar system like a protective blanket. And then it will go beyond. It will travel for thousands of years, passing through the emptiness between the stars. It seems lonely perhaps, but look closer. It is surrounded by the stars. When you lie in your bed in the dark, you are seeing the same view that the comet sees. The darkness is not empty. It is a canvas. It is filled with the light of billions of suns. Some are blue and hot, some are red and old. They twinkle like diamond dust scattered on black velvet. You are a part of this. The atoms in your body, the iron in your blood, the calcium in your bones, they were all forged in stars just like those. You are not separate from the universe, you're a child of it. Resting here in your bed is like resting in the cradle of creation. The comet 3I Atlas is leaving us, but it leaves us with a gift. It reminds us that everything is in motion, and yet everything has a place. Problems that seem so big this morning are actually very small when you look at them from deep space. The worries of tomorrow are microscopic compared to the galaxy. They cannot touch you here. In this moment there is only you, the soft rhythm of your breathing, and the infinite sky. The comet is so far away now, it's just a speck. It is fading, fading, fading. It enters the interstellar night. It will wander the galaxy forever, a silent traveller witnessing the birth of new stars and the sleeping of old ones. It has done its job. It brought us wonder, and now it brings us peace. Let it go, watch it disappear into the black. Everything is slowing down. Your thoughts are becoming like the comet, drifting further and further apart, moving slower and slower. They float by, but you do not grab them. You just watch them pass, heading into the dark. The universe is big enough to hold all your dreams. It is big enough to absorb all your fears. You can let go now. The earth will keep spinning. The sun will rise again in the morning without you needing to do anything. The stars will keep watch overhead. You are a traveller too, but tonight your journey is inward. You are travelling into the landscape of sleep. It is a warm, dark, soft place. Atlas is gone now. The sky is empty of its presence, but full of peace. Silence, darkness, starlight, rest. Drift along the currents of the night. Float weightless in the safety of your bed. The darkness is gentle. The quiet is kind. Sleep now, deep restful sleep. Good night, traveller. Good night.